5 grams and autonomous vehicles, shaping the future of transportation. Title: 5 grams and autonomous vehicles, shaping the future of transportation. Introduction. The realm of transportation has always been subject to constant innovation and technological advancements. With the rise of the fifth generation of wireless technology, commonly known as 5 grams, and the evolution of autonomous vehicles, a promising future for transportation is unfolding. This article explores the intersection of 5 grams and autonomous vehicles and how this convergence is revolutionizing the way we move. 1. The advent of 5 grams technology. 5 grams, the successor to 4 grams LTE, promises increased speed, lower latency, and improved reliability. It has the potential to transmit data up to 10 times faster than its predecessor, making it a game-changer for various industries, including transportation. This next-gen technology utilizes higher frequency bands, more advanced antennas, and greater network capacity, forming a robust network infrastructure for a more connected world. 2. The rise of autonomous vehicles. Autonomous vehicles, often referred to as self-driving or driverless cars, have rapidly gained traction in recent years. These vehicles leverage various technologies, including artificial intelligence, sensors, and machine learning algorithms, to navigate and operate without human intervention. With the potential to enhance road safety, reduce traffic congestion, and improve energy efficiency, autonomous vehicles hold immense promise for the future of transportation. 3. 5 grams empowering autonomous vehicles. The fusion of 5 grams and autonomous vehicles is a marriage of convenience, creating synergistic effects for both technologies. The ultra-low latency of 5 grams enables real-time communication between multiple vehicles, infrastructure, and pedestrians, crucial for the safe and efficient operation of autonomous systems. Combined with high-speed data transmission, 5 grams provides the necessary backbone for the robust and uninterrupted connectivity required by autonomous vehicles. 4. Enhanced vehicle-to-everything, V2X, communication. Vehicle-to-everything, V2X, communication represents an essential aspect of autonomous driving. It encompasses vehicle-to-vehicle, V2V, vehicle-to-infrastructure, V2I, and vehicle-to-pedestrian, V2. Communication. 5 grams fast and reliable network connectivity facilitates seamless V2X communication, allowing autonomous vehicles to exchange information with each other, traffic signals, and even pedestrians. This capability enhances safety, facilitates smoother traffic flow, and mitigates accidents. 5. Smarter traffic management. The implementation of 5 grams enabled autonomous traffic management systems will revolutionize how we navigate urban environments. With real-time data transmission, traffic patterns, road conditions, and congestion information can be reliably relayed to autonomous vehicles. This data can help cars optimize routes, reduce fuel consumption, and minimize travel time. Additionally, smart traffic signals powered by 5 grams can respond dynamically to traffic conditions, reducing congestion and improving overall traffic flow. 6. Remote vehicle control. 5 grams ultra-low latency plays a significant role in allowing remote control capabilities for autonomous vehicles. This feature holds tremendous potential in emergency situations, where a remote or can take control in critical moments. It also offers opportunities for remote vehicle maintenance, diagnostics, and software updates. The ability to remotely control autonomous vehicles is a significant step towards enhancing safety and operational efficiencies. 7. Augmented reality, AR, integration. The combination of 5 grams and augmented reality, AR, presents revolutionary possibilities for autonomous vehicles. AR can overlay real-time information onto the driver's field of view, displaying crucial data such as navigation instructions or hazard warnings. With its ultra-low latency, 5 grams allows for smooth and uninterrupted AR integration, contributing to a safer and more immersive driving experience. 8. The challenge of infrastructure development. While the potential of 5 grams and autonomous vehicles is vast, their successful deployment relies heavily on infrastructure development. The integration of 5 grams networks requires a significant increase in the number of small cell towers, fiber optic cables, and network equipment. Furthermore, the development of autonomous vehicle infrastructure, such as intelligent roadways and advanced traffic management systems, is crucial for seamless implementation. Collaborative efforts between private industry and public entities will be necessary to overcome these infrastructural challenges. 9. Economic and environmental impacts. In addition to the technological advancements and improvements in transportation, the convergence of 5 grams and autonomous vehicles also has significant economic and environmental implications. With reduced congestion and optimized traffic flow, autonomous vehicles powered by 5 grams can potentially minimize fuel consumption and carbon emissions. This could contribute to mitigating climate change and creating a more sustainable future. Moreover, the deployment of autonomous vehicle fleets and related infrastructure could generate new job opportunities and stimulate economic growth in various sectors. 10. Regulatory and legal considerations. As the adoption of 5 grams and autonomous vehicles accelerates, it is essential to address the regulatory and legal aspects associated with these advancements. Governments and regulatory bodies must develop comprehensive frameworks that ensure safety, privacy, and security in autonomous transportation systems. Issues such as liability, data protection, and cybersecurity need to be carefully addressed. To build trust in this transformative technology, collaboration between industry stakeholders, policymakers, and legal experts is crucial to create a conducive regulatory environment. 11. The road ahead. While the integration of 5 grams and autonomous vehicles brings forth tremendous opportunities, challenges still lie ahead. Technology reliability, cybersecurity, and public acceptance are key areas that require continued attention and improvement. Reliable connectivity and seamless transitions between 4 grams and 5 grams networks are essential to ensure uninterrupted communication and operation of autonomous vehicles. Additionally, public education and awareness campaigns are necessary to foster acceptance and trust in the capabilities of autonomous transportation systems. 12. Collaborative innovation. The successful convergence of 5 grams and autonomous vehicles necessitates collaboration and innovation across various sectors. Not only are technology companies and automakers involved, but partnerships with telecommunications companies, infrastructure developers, and policymakers are also crucial. 13. Global adoption and connectivity. The impact of 5 grams and autonomous vehicles extends beyond individual cities or countries. This technology convergence has the potential to revolutionize transportation systems on a global scale. However, ensuring widespread adoption and connectivity is a significant challenge. It requires coordinated efforts among governments, organizations, and global standards bodies to establish a uniform regulatory framework and promote interoperability. International collaboration and cooperation will be essential to harness the full potential of 5 grams and autonomous vehicles for the benefit of all society. 14. The human factor.